Alright, so what do we do? Show what? Show it is true. There's probably people out there that won't like me doing this with it. True for n equals 1. So what do we got? 7 times 1 plus 9, that's our left hand side, equals 1 outside of 7 times 1. I'm being stupid, I'm writing the whole thing in for a second. So that's 16. What's that? Can you see the 32 on 2, which is 16? So is it true for n equals 1?
Yes.
Yes. So we could make a statement true for n equals 1. Next step, assume. So what do we assume? Assume, if I was fussy, it is true for n equals k. Why do people use k? Because everyone does. I don't know. I'm mentioning to research it, see if you can find out why people went to the letter k. So what have we got? Go to the original statement, 16 plus 23 plus 30. How many terms do you need to establish a pattern?
3.
3. So most people will write that with 3, and they're dot, dot, dots and over there. And then that will be k, 7k. So all we've done is replace the n by the k. Okay? Oh, you're okay. No way to say it. Next term. Now there's 2 possibilities for this, okay? There's 2 ways that people will approach it. Let's go to the next term. Do people write next term? No. I'm just writing it down for us at the moment. If you want to do that, it's acceptable. So I can go 16 plus 23 plus 30, get to that term, and add the next term. What's the next term?
7k plus 1 plus 9.
Yeah. So you're replacing the k by k plus 1. So I'm thinking about what would someone think if they've never seen induction before. Well, you guys have seen it before. So I replace the k there by the k plus 1. So this adds the next term to it, so that is the next term. And over here we can go k plus 1, and then you can go 7 outside of k plus 1. So what have we done on this side? We've added the next term, but on this side we've replaced the k by the next term. Can you imagine what some people do? They do this. I'm going to write it over here and then rub it off. I'll go 16 plus 23. Then you've got k. And I can see why a lot of people like this. In some ways it's maybe what you call more pure. So if you look at this way of doing it, am I taking 2 on this? Probably. We've added the extra term there, we've added the extra term there. At that point, if I took that approach, I could have turned that into that, or that into that. Could do something to show that the 2 are the same. I could manipulate this, I could manipulate that. Those who are really, really good at their maths will go manipulating this and turning all of this bit here. So that's probably, I'd call that a more pure approach. They turn that algebraically into that. What I don't like about that, what my brain doesn't naturally do, is get all these k plus 1s. I'm going to show you something there. If I expanded all that out to something else, so I could go, that's k plus 1, I'm going to rub this off in a second, and that's 7k plus 7 plus 25, 32. Make sure I don't make a mistake. If I wrote that like that, I can easily factorise that, or fractions, and factorise it into that. But I find it much harder to factorise it into that form. So if you wanted to go that approach, you can. It's not that hard. I can do all sorts of things to get there. I'm going to start it, but not finish it. So if someone's watching this, and their teacher takes this approach, they'll ignore all this here, and they go, let's put k outside of 7k plus 25 on 2, and they'll go, I want this to be on 2. So I'm going to have double that, 14k plus 1, double that, 18. You okay with what I just did?
Yeah.
It's actually back to my equals of times 1, we've just gone times 1 times by 2 on 2. And then I can go put that together and then factorise into this, or better still, factorise it into that. So I'm going to do a little bit of it. Let's go that 7k squared, that's 25k, it's all over 2 plus 14k plus 14 plus 18. And you got 7k squared plus, what have I got? 39?
39k plus 32.
Yeah. And how good at you are you at factorising that?
Need a bit of thought.
You know what's stupid? I can look at this and say, there it is. Or you can go through, how do I factorise that? Old school, we'd go 7k and k, that method. So there's about 3 or 4 different methods. We'd go back to that, and watch what I've got. 1 and 32, 32 and 1, 2 and 16, 16 and 2. You with me? 4 8s are 32, 8 4s are 32. Are there any other possibilities? So do you guys even think that method?
Not really.
It's not bad when it gets, I reckon when it gets yucky, gets more revolting, and everything's plus especially nice, a bit easier. It gives you the fail-proof method. By the way though, if I expanded this out, that'd be 7k squared. I could expand that out and show it's that anyway. So you can do a mixture if you're not a Puritan. You can go, I'm going to get that, I'm going to get that, and I know this is just 7k plus 32 equals k plus 1, and you've fudged it, haven't you? You can check it's true though. Or instead, you could do this. I want to just talk about what happens in maths, okay? Let's just get this one out here. So that's 7, this is the left-hand side. So some people will go left-hand side, and you'll go 7k squared. You okay with that? 32k plus 7k. Come on, 32k.
39k
39k
plus 32.
plus 32 on 2. And you go equals right hand side. And your proof's done. So let's get away from this for a second. And what have I done instead? This approach. I've just made the next term, there's the next term, and I've replaced the k by the k plus 1. And what are we going to do? Next thing is, this is what I prefer this approach for, is that one. Assumption. So where's our assumption? I do love, as you know, going, there it is. What's it got to do with anything? Well, I know that that, which is that, can be replaced by that. Let's have a look what it does. So now I've got k, 7k, plus 7k plus 1 plus 9 equals what? 1, 2. And guess what we got? Basically everything we did a moment ago. So you can go add a term, extra one, and add an extra term, or you can go turn that into the next term. Introduce the next term. Now you've got all the algebra again. Now my heart more than my brain, will go, oh, I don't like the look of that. Then I'll go that 7k, 7 plus 20. I'm back to the same algebra I did a moment ago. So I've still got to put this together to be that. So there's really no difference in the two methods. So do I get more fussy on this than I was last time? That's on 2, so I want that to be on 2. Yeah?
Just
So
double
wait,
both.
double the bottom, double the top. Imagine how much I could abbreviate this. That's 18 on 2. So now I've got 7k squared plus 25k plus 14k plus 14 plus 18 all over 2. Do I need to keep writing this all down? A lot of people don't. I can deal with it. This is just the left-hand side if I wanted to. So what have I got? I'm back to 7k squared plus the 39k plus the 32 on 2. And guess what? I know because I'm brilliant that is k plus 1 7k plus 32 on 2. I could have done it if I wanted to, but you saw me do it, I know, again.
Very humble, sir.
Oh yeah, very humble. Therefore, true by, now do we have to write the words of mathematical induction? True by induction. And I think about it'd be better to say for n greater than or equal to 1.